Hi and welcome to reactions of alcohols within our Module 7, Organic Chemistry. Now, ethanol is one of the most widely used alcohols in society, and the vast majority of ethanol produced is used in the automotive industry. E10 fuel classification indicates that the fuel contains about 10% ethanol. And the presence of that hydroxyl group means that ethanol has some very different properties in comparison to ethene and chloroethene. And these properties make it really valuable for a wide variety of applications. Ethanol is a highly water-soluble liquid, and it's widely used as a solvent in the pharmaceutical industry and the cosmetic industry, as well as in your alcoholic beverages. And when it's consumed, it can act as a suppressant, allowing reactions, slowing of responses. And excess ethanol consumption can also block your antidiuretic hormones, which increases your urination and resulting in dehydration, which is why you get thirsty. But let's look at some of those other properties of our reactions of alcohols. Now, combustion is one of our obvious ones here. Like our alkanes and our alkenes, they burn readily in air to form our carbon dioxide and water. And it is a highly exothermic reaction, which is why we can use it as a fuel. And in class, you would have done your experiment on the combustion of alcohols and determining the difference between our different alcohols that we had on hand. Now, the reaction that we have here on the screen is a reaction that is complete combustion. But in many instances, our combustion is not complete and soot is also formed, and we call that incomplete combustion. And in many of our cases, there is not excess oxygen available, and incomplete combustion actually does take place. So the enthalpy of combustion, and here is our outcome that we're looking at, conducting a practical investigation to measure and reliably compare the enthalpy of different alcohols with their heat of combustion. And we need to remember back to our Year 11 course again, where we're looking at that enthalpy of combustion. So our specific heat capacity of the substance is the amount of heat required to increase the temperature of the mass of our substance by 1 degree Celsius or Kelvin. Now, that specific heat capacity, and it's always really important that you look at the units that they have got in the question. Here it can be joules per Kelvin, sometimes it could be kilojoules per Kelvin, and it's a real trap, and you need to make sure that you're mindful of that. And is it per gram or is it per kilogram? And making sure you have your units that you're inputting into your equation in the correct form. Now, specific heat capacity of water is essential for our calculations and is 4.18 times 10 to the 3 joules per Kelvin per kilogram. Now, this equation should not be unfamiliar to any of you. Q is equal to mc delta T, where delta T is the change in temperature. C is the heat capacity of the substance. M is the mass of the substance in grams, and Q is the quantity of heat transferred. So it is how much heat is being transferred to the substance that we are heating, and in this case it was water. If Q is negative, the reaction is exothermic, and if Q is positive, the reaction is endothermic. So you're going to need to know if reaction has been released, that your Q will have to be negative. So that is our quantity of heat that is transferred, but that is different to our molar heat of combustion. And with our molar heat of combustion, we're actually looking at how much heat is released or absorbed, but released with the case of our alcohols when we burn 1 mole of that compound. So it's not just how much was burnt in your experiment, but actually the amount per mole. So you're going to need to do those calculations to make it easier to compare between the different alcohols that you are studying. So looking again here, our change in enthalpy is defined as the heat released or absorbed per mole. And that's when we have standard lab conditions, so constant temperature and pressure. And for combustion reactions, it is always negative because they are exothermic and releasing heat. So we're going to do a few more of those calculations in class to really make sure we nail those and make sure that we have got those sorted. We'll talk about those a little bit more in class. See you then.